Welcome to Hartman Math. Before we get to more trig formulas, identities, we're going to work on, in our warm-up here, solving some trig equations and verifying an identity. Pause here as you work through the three problems. All right, number one, two different functions. That is one that we're going to need to square both sides so that we can then use the Pythagorean identity. Square both sides, and then because we're not going to be able to change that, this is the one that we want to go after. We're going to change that using the Pythagorean identity, 1 minus sine squared x, then get everything to one side, then factor out a greatest common factor. So cosine x equals 0, cosine x equals -1. We are solving on 0 to 2 pi, so where is cosine of x? 0? Up and down, so pi over 2, 3 pi over 2, whereas cosine of x -1, that's at pi. Keep in mind, because we did square both sides, the 3 pi over 2, when we try that, doesn't work. So remember, when we squared both sides, that does give the possibility of extraneous solutions. You've got to make sure you check all of your answers. Number 2 is a multiple angle problem, so even though it says 0 to 2 pi, we are going to have to initially go with the plus 2n pi because it's cosine. So if we isolate, cosine of 2t is going to be a half. Where does that happen? In the unit circle, the x-coordinate is a half at pi over 3 and 5 pi over 3. So 2t equals pi over 3 plus 2n pi, 5 pi over 3 plus 2n pi. Let's get rid of the 2, divide both sides by 2, divide both sides by 2. And then if we start substituting in values of n starting at 0, we're going to get pi over 6 and a 1, 7 pi over 6. And then the next one, 2, is going to be too big outside of our interval. So remember that we're just only getting 2 values from here. So pi over 6, 7 pi over 6, 5 pi over 6, and 11 pi over 6. Those are our 4 solutions. All right, our verify. So picking a side to work on. Maybe this one, maybe we go in terms of sines and cosines. And then let's see if we can add these together. We're going to need to create the common denominator. Multiply top bottom by sine x, top bottom by cosine x. Pythagorean identity. And if we split this up as 1 over cosine x times 1 over sine x and then do reciprocals, we're there. This is lesson 5.5, multiple angle and product to sum formulas, and there's some others as well. The double angle formulas, sine is pretty basic. Sine of 2u is 2 times sine u times cosine u. For cosine of 2u, you have 3 different options. You have cosine squared u minus sine squared u. By Pythagorean identities, we can replace either one of those, and so we can get 2 cosine squared u minus 1, or 1 minus 2 sine squared u. Tangent of 2u, 2 tangent u over 1 minus tangent squared u. That one kind of looks like tangent of u plus u, so it has similarities to the previous formula for tangent. Example number 1, solving a multiple angle problem. So our issue in this one is not only having 2 different functions, but having 2 different angles. We've got x and we've got 2x. So I'm going to go after this one first, then we'll see if we need to do that one. But cosine 2x, we need to meet cosine x, so we're going to use the double angle formula for cosine. Now we have 3 options, remember. Which one do we want to use? Well, since the rest of the problem is sines, I think I want to use the one that's sine. So 1 minus 2 sine squared x. Now if we combine like terms, we get sine squared x equals 1. That can be factored. We could do the square root method. If we do the square root method, we're adding 1 to both sides, square rooting both sides. Don't forget positive, negative. So we got sine of x is positive or -1. And it is just a solve, so no particular interval. So we're talking about where is the sine of x, 1 or -1? It's 1 straight up, it's -1 straight down. So pi over 2 plus 2n pi, 3 pi over 2 plus 2n pi, or since those are equally spaced, we could say pi over 2 plus n pi. That takes us from here to here and then back. So pi over 2 plus n pi, where n is an integer. Remember, for WebAssign, you don't need that part. For writing this down and submitting paperwork, you need that part. Again, you could have said pi over 2 plus 2n pi, as well as 3 pi over 2 plus 2n pi. That would also work. This is more efficient. Checkpoint. Pause here as you solve. Again, you've got two different angles. That may be where you want to attack. All right, so we're going to go after this one again. Based on that, I think I want to use the option for the double angle for cosine that's all in cosines. So 2 cosine squared x minus 1. And then we kind of regroup it, put it in the correct order. It then factors. Cosine x equals a half, cosine x equals negative 1. And where is it? So we're talking about in terms of sketch, pi over 3, 5 pi over 3, and pi. Ooh, those are all 2 pi over 3 apart. So we were able to go with just the 1 pi over 3 plus 2 and pi over 3. You could have said pi over 3 plus 2n pi, 5 pi over 3 plus 2n pi, pi plus 2n pi, where n is an integer. Example number 2, evaluating functions. Use the condition to find double angle for sine, double angle for cosine, double angle for tangent. Different ways of approaching. So here's what we have, the information, given some information, told about what quadrant it's in. So quadrant 3, where tangent is 8 over 15. Let's sketch that out. So we're sketching our angle theta based on a trig triangle where opposite, adjacent, since we're talking about quadrant number 3, both of those are going to have to be negative, so we're talking about left and down. So a little sketch. And since we're going to be using some of these, I think we're going to need to find that hypotenuse. So a squared plus b squared equals c squared, or knowing your Pythagorean triples, we're going to get 17. So now, for sine of 2 theta, it's 2 times sine theta times cosine theta. We're going to get sine theta and cosine theta from our sketch. So 2 times, sine theta is negative 8 over 17. Cosine theta is negative 15 over 17. So 2 times negative 8 times negative 15 on top over 17 times 17, our final answer, 240 over 289. Cosine of 2 theta, we've got multiple options. We can go a lot of different ways. I kind of think this one might be the easiest one computationally here. Talking about cosine squared theta. So remember, here was our cosine theta. If we square that, we're going to get positives. 225 over 289 minus 64 over 89. We're going to get 161 over 289. Tangent, we have the formula for tangent, but since we've already done sine and cosine, if we just use quotient identity, tangent of 2 theta is sine of 2 theta divided by cosine of theta. Sine divided by cosine, remember, since the denominators are the same, they'll cancel out. We're just going to get 240 over 161. 240 over 161. Here's some other formulas. Power reducing formulas. Sine squared u, cosine squared u. And this takes us into double angle. And tangent squared u. And it takes us into some double angle situations. All right, example number 4, reducing a power, calculus application, rewrite sine squared x times cosine squared x in terms of the first powers of cosines of multiple angles. So from our previous sine squared, cosine squared, there's our first replacement, our first substitution. Now we can multiply these together, difference of squares on top, 2 times 2 is 4 on the bottom. From there, might be best to factor out 1/4. So 1/4 times 1 minus 1/4 here would be the cosine squared 2x. Now here's our problem. It's supposed to be in terms of first powers. So notice the cosine squared 2x, it's a lot like this one right here, except now we're talking about double angle. So 2 times our angle is now 2 times this angle. So factored out the 1/4, 1 minus, and then this is going to become 1 plus cosine of 4x, because 2 times 2x is 4x, over 2. So now if we multiply the 1/4 into all of that, it splits it into 3 terms. And we can combine like terms right there. And there's our final answer in terms of 4 powers, and here's our multiple angle. Half angle formula. So if we want to take sine of half of an angle there, positive or negative, you will need to make that choice. It's not going to be both. It's going to be depending on the quadrant that u over 2 is in. Not u, but u over 2. Anyway, positive or negative, you will choose square root of 1 minus cosine u over 2. Cosine very similar, positive and negative, except it's 1 plus cosine u over 2. And then the tangent of u over 2. I usually prefer this one. It's usually easier to have a monomial denominator, but either is true. As it says here, the signs of the cosine and sine of u over 2 depend on the quadrant that that angle is in, not that angle. Example number 5. Find the exact value of the cosine of 157 degrees. Oh, this is new notation. And 30, the apostrophe. 30 apostrophe means 30 minutes. So thinking of that in terms of a clock, 30 minutes is half of an hour. 30 minutes in this context is half of a degree. So we are talking about 157.5 degrees. In which quadrant would that angle lie? Quadrant 2. It's between 90 degrees and 180 degrees. That's our u over 2. Now we want to find the u. What's being divided by 2 to get that? Well, if we double it, if you take on your calculator 157.5 times it by 2, you're going to get that the u is 315 degrees. This is half of 315 degrees. The reason that we do this is not a unit circle angle, but this is a unit circle angle. So we can evaluate this. So now we're going to use our formula, positive or negative, square root, fraction 1 plus cosine of the u divided by 2. You're going to need to choose positive or negative. It does not depend on the 315. It depends on the 157.5. Which quadrant was this in? Quadrant 2. In quadrant 2, what's cosine? Negative. So we're going to choose the negative answer here. What's the cosine of 315? We're talking about quadrant number 4 there. We're talking about root 2 over 2. So we've chosen negative. 1 plus root 2 over 2 over 2. To simplify this, we're essentially going to take a fraction busting technique, multiply top and bottom by the denominator here. So we're going to multiply everything by 2, top and bottom. So 2 plus, the 2's canceling, 2 plus root 2 over 4. Now we're going to break it up, square root top, square root the bottom. We can take the square root of 4. So our final answer, negative, out in front. Square root of 2 plus root 2 inside, all over the 2 as we simplify. Example number 6, solving a trig equation based off of that. So again, we've got a formula for sine of x over 2. It will be squared. Sine of x over 2 is either positive or negative. Square root, the fraction, 1 minus cosine x all over 2. So we'll start there with that replacement based on that formula. Half angle for sine, it is going to need to be squared. It's got 4 out in the front. Now when we go ahead and square this, it really doesn't matter if it's positive or negative, because when you square a positive, you get a positive. When you square a negative, you're going to get a positive anyways. So the sign ambiguity is just going to disappear. And when we square the square root, we're going to get 1 minus cosine x over 2. as the exponent and the root cancel out. 4 times this. 4 divided by 2 is 2, so we can distribute that 2 in, and then subtract 1 to get it equal to 0. Now we're ready to factor. Factor it out. We get cosine x minus 1, another cosine x minus 1, also known as cosine x minus 1 squared. That means that cosine of x minus 1 is going to equal 0. We square root both sides, so cosine of x is equal to 1. Where does that happen? 0. Here are the product to sum formulas. So if we have a product, we can convert into sums. So have access to these formulas. Writing products as sums. So can we rewrite this product as a sum or difference? So we're going to kind of try to match up to here. We've got cosine times sine. Cosine times sine. Here's our u. Here's our v. It says 1/2 times sine of, add them together, 9 pi, minus sine of, subtract them, 2 theta minus 7 theta, negative 5 theta. So there's our setup. Now keep in mind for our answer here, 1/2 sine 9 pi plus sine of 5 pi. What we did here was used another identity. Sine of negative 5 theta, I'm sorry, theta, not pi, negative sine of negative 5 theta. Well, in terms of odd-even identity, sine is an odd function. So the sine of negative 5 theta is negative sine of 5 theta. And negative negative becomes plus. That's why we have plus sine of 5 theta by simplifying and using identities. And probably more useful than that are sum to product formulas. These could be useful in solving equations, because if we can get to being products, if it's equal to 0, then we can use the zero product property. So that would be the benefit here. If it's sine plus sine, it looks like this. Sine minus sine, cosine plus cosine, cosine minus cosine. Have access, come back and look at, figure out what we need. Find the exact value of each of these. Well, if it's cosine plus cosine, we can go back here and say it's 2 times the cosine of the sum divided by 2 times the cosine of the difference divided by 2. So the sum would be 6 pi over 12. That's pi over 2. And the difference is negative 4 pi over 12, which is negative pi over 3. So here's our setup. 2 times cosine sum divided by 2 times the cosine of the difference divided by 2. So pi over 2 divided by 2 is pi over 4. Negative pi over 3 divided by 2 is negative pi over 6. Now we can evaluate. Cosine of pi over 4 is root 2 over 2. Cosine of negative pi over 6, so back into quadrant number 4, whether we want to use an identity or not, your choice. We're down into quadrant 4 where cosine is positive, and we're talking about short way down, so x is long going out, so positive root 3 over 2. So now if we multiply those, this 2 cancels with this 2, we're going to get root 6 over 2. Example number 9, solving. Equal to 0. Okay? There's no factoring that can be done here. Okay? You can't factor out a cosine of 3x. It doesn't work that way. What we can do is use one of those identities. Cosine minus cosine. Where it turns out to be negative 2 times sine, add them together and divide by 2. Times the sine of subtract them and divide by 2. As this equation equals 0, We can divide both sides by the -2 and get rid of that at any time. We simplify. So if it's product and we split it up, this equals 0, this equals 0. So for this equals 0, where is the sign of any angle equal to 0? Zero and pi. So 0 plus n pi gets all of them. Same thing here. If we solve for x, multiply by 2 divided by 9, multiply by 2 divided by 3. All of these are covered by these anyway, so it would be redundant to list them both, although it's true. Okay, if we're talking about this one being 2n pi over 3, as I said, they're in here. If I plug in a 3, I'm going to get 2 pi over 3. That's it for today. I'll see you next time.